Well, hey, welcome to part 3 of basic right triangle trigonometry. In parts 1 and 2, we took some time to talk about what trigonometry is, how similar triangles help us establish these trigonometric ratios. And today in class, we kind of talked about what it means when you push like the sine of 30 degrees in your calculator, how your calculator comes up with that number, that fraction, that decimal, that ratio, where that ratio comes from. So today, I want to look at what happens if you're looking for missing angles, not sides. So remember, we established this little saying to help us memorize our trig ratios. Some old horse caught another horse, taking oats away. Sine, opposite over hypotenuse. Cosine, adjacent over hypotenuse. Tangent, the opposite over the adjacent. So let's do a warm-up problem just to make sure we remember all the trig that we learned the other day. So here we have a right triangle, and I know one side is 12, but I don't know x. And I don't have the other side. I mean, if I had the other side, I could use the Pythagorean theorem, but I don't have it. But instead, I have an angle. So this is a great opportunity for some trigonometry. So trigonometry all depends upon where you're standing, because where you're standing determines which side is the opposite and which side is the adjacent. So if we stand right here where this 50-degree angle is, I can see that 12 is the hypotenuse, and I can see x is the adjacent side. So adjacent and hypotenuse, that's a cosine function. So I know the cosine of 50 degrees, remember, cosine is a function. It has to attach itself to some angle. So the cosine of 50 degrees is the adjacent over the hypotenuse. There's a little algebra involved. We have to get x by itself. And of course, you undo division by its complete opposite, which is multiplication. So I'm going to multiply both sides by 12. And I get x equals 12 times the cosine of 50. Now I'm ready to pull out my calculator, and I can type into my calculator 12 times the cosine of 50 degrees, and I get 7.71. So that tells me x is about 7.71. And that's great. And that was the trigonometry lesson we learned in parts 1 and 2. But now we're going to take a look at triangles that are slightly different. Now, instead of having a missing side, we have missing angles. So, how do we use trigonometry to find missing angles? Well, first thing we have to do is pick an angle to go after. We could either go after x or y, it doesn't matter. But since we have to choose, let's go after x first. So I'm going to stand right there at that x. And standing at that x, I see 13, which is my hypotenuse. And standing at this x, I see 9, which is the opposite side. So, if I pull up my little some old horse caught another horse taking oats away, the opposite in the hypotenuse, that's the sine function. So I'm going to say the sine of x is the opposite over the hypotenuse. Now, the question becomes, how do we get x by itself? And this is a brand new thing for you. This is a new idea that you've never experienced before in a math class. And that's that sine isn't a number. Sine is a function, and functions are much different than numbers. So we can't divide both sides by sine because it's not a number. So we have to think about what gets rid of the sine function. Well, think about operations. If I want to get rid of multiplication, I have to do the complete opposite of multiplication. And that would be division. If I wanted to get rid of, say, addition, then I would have to do the complete opposite of addition. And that's subtraction. And if I wanted to get rid of, say, squaring a number, I would have to do the complete opposite of squaring a number, which is a square root. So you're probably wondering, what's the complete opposite of sine? And that would be this. This symbol is read as the inverse sign. Sometimes it's called the arc sign. And it looks like it's signed to the negative first power, but this negative 1 that's shrunk down and stuck in the corner, much like an exponent, although it's not an exponent because sign's not a number, is an inverse or an undoing. And if you look at your calculator, you'll notice that right above the sign button, in my calculator it's written in blue, is this inverse sign. It's the thing that undoes the sign. And that's, look at the squared button on your calculator. See x squared? See how right above it in blue is the inverse or the opposite of squaring, a square root? So what I'm going to do to get rid of the sign is I'm going to take, do you hear my word? Take the inverse sign of both sides. Now I'm not multiplying by the inverse sign because it's not a number, it's a function. So we say we take the inverse sign. Now, sine and inverse sign are complete undoing functions. They undo each other. So when you take the inverse sign of the sine, they completely cancel each other out, and we're left with just x. So we get x equals the inverse sign of 9/13. So now we're ready for our calculator. We type it just the way we see it, the inverse sign. Now the inverse sign is its own button. It's that little blue button right above the sign button. So I hit second inverse sign of 9 divided by 13, and that gives me about 43.8 degrees. So x is about 43.8 degrees. And that's my x. So that's how we use inverse functions to undo a function. So let's go after y now. So if we want to go after y, maybe we stand over here. And we're standing in a new spot. Now, if we're standing here at y, 13 is still the hypotenuse, but 9 is no longer an opposite side. What 9 is an adjacent side. It's next to the smiley face, next to the y. So adjacent and hypotenuse, that would be a cosine function. So the cosine of y is the adjacent over the hypotenuse. So how do we get y by itself? What's the only thing strong enough to break apart a cosine? The only thing strong enough to undo a cosine would be this, the inverse or the arc cosine. So what I'm going to do is I'm going to, listen to my words, I'm going to take the inverse cosine of both sides. And what that does is inverse functions completely cancel out whatever the function is doing, and we're left with just y. So we'd be left with y equals the inverse cosine of 9/13. So I get out my trusty calculator. The inverse cosine button is located right above the cosine button, so I have to hit second cosine of 9 divided by 13. And what that gives me is about 46.2. And that's how I can find y. But you know what? Now that I'm looking at this problem, I think I probably wasn't that efficient. I mean, once I found x was 43.8, can't I find y just by doing some basic subtraction? I mean, don't we know that these two angles would have to add up to be 90? So wouldn't y just equal 90 minus 43.8 right here? And so I actually could have found y much quicker, 46.2, just using some subtraction. So let's try a problem all by yourself. Here's one. Why don't you pause the video, set up your trig ratio, find x first, and then see if you can find x. Come back to this video once you found x. Well, hey, welcome back. Your goal was to find x, so you probably put your little smiley face there. You're going to stand where x is. You look out into this triangle. You see 5 is the opposite side and 12 is the adjacent side. You probably wrote down your some old horse caught another horse taking oats away. What compares opposite to adjacent? Well, that's the tangent function. So we could say the tangent of x is the opposite over the adjacent. So now we have to get rid of tangent. Well, the only thing powerful enough to undo a tangent is, you guessed it, the inverse tangent. So we take the inverse tangent of both sides. And when we do that, an inverse of a function matching with the function, they completely undo each other, and we're left with just x equals the inverse tangent of 5/12. So I go into my calculator and I say the inverse tangent. Now inverse tangent is right above tangent. So second tangent of 5 divided by 12. And that gives me x is about 22.6. So hopefully you found that on your own. And now that we have x, we can go after y by being smart and using just basic subtraction. Y is 90 degrees minus 22.6. Of course, I'm saying 90 because I already used up 90 degrees of my triangle. So y should be about 67.4. Okay, let's go ahead and try another problem. Here's another problem. This time you have to find x, y, and z. So pause the video and give it a try. Welcome back. Hopefully you paused the video and you tried. I'm going to go after x first, although it technically doesn't matter. Standing here at x, looking out, I see that 5 is the opposite and 10 is the hypotenuse. So if I pull up my little saying about horses, opposite and hypotenuse is sine. So the sine, the sine of x is opposite over hypotenuse. That shouldn't be there. And then to get rid of the sine, what I had to do is I had to take the inverse sine of both sides. And remember, an inverse will completely cancel out whatever the function was doing. So we end up getting x equals the inverse sine of 5/10. So I can go to my calculator, I can type in the inverse sine of 5 divided by 10, and this one turns out to be a really nice, pretty number. It's just 30. X is 30 degrees. And now that I know x is 30 degrees, I can find y by some simple subtraction. Y is going to be 90 minus 30, or 60 degrees. And then I could find my missing side z, not by using trigonometry, but by realizing, look, I've got a right triangle. And if I have a right triangle, and if I know two sides of that right triangle, this side is 5 and this is 10, I can find z using the Pythagorean theorem. So using the Pythagorean theorem, we know z squared plus 5 squared equals the hypotenuse squared. And we can go through and solve for z and simplify this square root and get z is 5 radical 3. One more problem. This last one I want you to do all by yourself. So pause the video, try it, come back in once you found x and y and z. Okay, so welcome back. I went ahead and set up my little horse story. I decided to go after x first. So standing here at 28, standing at that 28, I have this 9 right here, which is what? That's the hypotenuse, and x is the adjacent. I'm sorry, what? 9 is not the hypotenuse, 9 is the opposite. So opposite and adjacent, that's the tangent function. So I said the tangent of 28 equals 9 over x. Now notice I'm not going to use inverse trig because x is not trapped in the function. X is outside of the function. So this becomes a problem like we did last time. Now I am a member of the shortcut club, so I'm going to just jump down and say x turns out to be 9 divided by the tangent of 28. If you're not a member of the shortcut club, go back and look at the last video and see how we get x by itself. Typing this into my calculator, 9 divided by the tangent of 28, I ended up getting that x is 16.9. Now, to find y, I'm still going to stand at 28. Y is the hypotenuse. The opposite in the hypotenuse is the sine function. I'm a member of the shortcut club, and that's what I got for y. And then finally z I got from some simple subtraction. So those are your notes today. Good luck on your homework.